The Pythagorean theorem gives us an equation that allows us to relate the three sides of a right triangle. Now, a right triangle is one where one of the angles is equal to 90 degrees, or is a right angle. And the Pythagorean theorem tells us if that is the case, if we have a right triangle, then if we square the sides and add them up, that is equal to the squared value or the squared length of the hypotenuse. And the hypotenuse is this like diagonal length here. So that is called the hypotenuse. Okay, so why do we care about the Pythagorean theorem? It comes in handy when we're dealing with real-world applications. Like example 9 says, a 20-meter long rope is stretched from the top of a 12-meter tree to the ground. What is the distance between the tree and the end of the rope on the ground? Now, I find it helpful to draw pictures a lot of the times. So here is my tree. And it says that the 20-meter long rope is stretched from the top to the ground here. And then we know that this is 12 meters long. The height of the tree is 12 meters long, and the rope is 20 meters long. And so it's asking, what is the length from here to the rope to the bottom of the tree? And we know that this here is a right angle. And so we're basically asking about that length there. Now, using the Pythagorean theorem, we can create the equation 12 squared, and instead of putting a question mark, maybe I'll replace that with a b. So we're trying to solve for the length of b. So 12 squared plus b squared is equal to 20 squared. Now, I can go ahead and square those values. So we have 144 plus b squared is equal to 20 squared is equal to 400. And if I'm trying to solve for b, I would subtract 144 from both sides and get b squared is equal to 256. Now, it's at this point that we want to solve for b and not b squared. And the way that we would do that is we would take the square root of both sides of our equation. And if we do that, on the left-hand side of the equation, we're just left with b. And let me show you where that is on your calculator. So you want to press second, and then the square root button is where the x squared button is there. And then we would type in 256 and press enter, and we get 16. So b is equal to 16 meters. Okay, so that one was nice because when we took the square root, we got a whole number, but sometimes that's not going to be the case. Example 10 says, a 13-meter long ladder is leaning against the wall. If the ground distance between the foot of the ladder and the wall is 5 meters, what is the height of the wall? So here is the wall of some building, and we have a ladder that is leaning against it. So there's my ladder. It's a very poorly drawn ladder, but it's still a ladder. And we know that the ladder is 13 meters long, and the ground distance between the foot of the ladder and the wall, so this length here, we know that that's 5 meters, and we do know that that's a right angle. And so let's call the height of the wall a. That is what we are trying to figure out. So we have a squared plus 5 squared is equal to 13 squared. And if we simplify that, so I would take the square root of both sides at this point, and we would get that a is equal to 12 meters. So the height of the wall here is 12 meters. So again, both of these examples, when we took the square root, we got a whole number, but oftentimes that's not going to be the case. So if it asks for an exact answer, let's say you end up solving something and you get like b is equal to the square root of 57. If it asks for an exact answer, then you would just leave your answer like that. And then if it asks for an approximate answer, if you threw the square root of 57 into your calculator, let's see what that gives us. So you'd get some long decimal, but depending on how many decimal places it asks you to round to, you might say that this is equivalent or approximately 7.55 if I rounded to 2 decimal places. So just read the question and see how it asks you to round it.